Hi, everyone. Hope you had a great weekend. It's Sunday, May 23rd, 2021. Today, we got a report on solar class flares because we're going through a geomagnetic storm right now. We're having issues from the sun, and the solar cycle is becoming pretty active. We're going to run through the different class flares for you. And they go as follows. Scientists classify solar flares according to their X-ray brightness in the wavelength range 1 to 8 angstroms. Flares classes have names A, B, C, M, and X, with A being the tiniest and X being the largest. Each category has 9 subdivisions ranging from e.g. C1 to C9, or M1 to M1 or M9, and X1 to X9. Now, the angstroms, what you see over here on the right, this is SDO. This is the Solar Dynamics Observatory. And they will show you different images of different angstroms of the different wavelengths. So this image you're seeing on the right is just one wavelength. This system of 1 through 9 and letters, it's pretty outdated, and I believe it needs to be updated with the new plasma physics in mind. And since this system came out, there's been so much that has come to light. So this system needs to be changed, and I'll show you something that shows that here soon. Okay, solar flares. Solar flares and Cmes send enormous amounts of energy and charged particles hurtling into collision with the Earth's upper atmosphere. Now, these charged particles, these are electrons, they're protons and alpha particles mainly, because it's from the corona mainly. It's the outer shell that's being blasted off into space, where they can cause geomagnetic storms. Charged particles during geomagnetic storms cause disturbances in the Earth's magnetic field, generating effects on electrical systems. Okay. These charged particles are usually at the range in between like 0.5 to, I think it's like 10 keV, depending on the class. But there's so much that has come out lately that they're saying there was one here. There's a link down here in this. Okay, the European Space Agency. Okay, back in 2003, there was a flare that occurred, and they ended up classing it as, no, this isn't the one. I think it's this one right here. Yeah, they ended up classing it as a X28. The biggest solar X-ray flare ever is classified as a X28. Okay, now I've heard people even say upwards of like an X1000 flare, which I don't think it is possible. But if it were possible from our sun, that is only going to happen every maybe 10 million years, who knows? But it's going to be a massive amount of time that something like that would ever occur out of our sun, being that it's an older sun. It's not a young sun. I mean, back when it was younger, I mean, it was releasing flares every single day. The huge flares every day. So it just steadily, as it ages, it's going to take a longer amount of time for these larger flares to come out. And our classifying system needs to show that better, because this system doesn't work. It's not right. Okay. So let's go ahead and head over to SDO. Now this is what's occurred. I think it was on the, let's see, the timestamp is the 22nd into the 23rd. And you can see there's a lot of activity coming off of this the sunspot here. And you can see it snapping, and just the shock waves go through the entire corona. It's amazing to really watch how much energy is released when that pops like that. When you have that mixing going on. Here, let me show you the mixing. I think, here, let me back out. I think they got a one. Yeah, here it is. Here's the mixing for you. You can see where the red and the yellow, that's the mixing of basically, I assume it's the plus and the negative mixing. And when it gets really mixed like that, there's like a discharge. It's basically, it's what do you call it? It's just shooting a lot of energy out when it comes into contact with each other. It's mixing a whole lot. So I mean, you'll see it gets to that point where it pulls itself around into that yellow. The red comes into that yellow a lot more, and it begins to mix right there. See it? And that's when you're seeing them pops and everything's happening at that point. It's like a short circuit. That's what I was trying to think of earlier. It's like a short circuit. Short circuits and then releases that energy. And you see those pops. I bring this full screen again for you guys, if I can find it. Yeah, I don't have it on here. They don't have the full screen, but we can still see it pretty good here. Wow, it's just popping. You can see the magnetic field coming out, that toroidal field, as it's being compressed and stretched as the solar dynamo wraps up, and it's compressing, and it's that creates them solar spot, then sunspots. Oh, did you see that lower one down there pop? Look at the bottom right. You'll see a spot. You can't really see a sunspot, but it pops right there on the bottom right. Here, it should be coming soon. Right there, right there. Wow, that was pretty cool. So yeah, you have the sunspot, you have the field coming in and out. So you have a leading spot and a trailing spot. And as the 11-year cycle goes towards the middle, you're going to see this peak out. Now, the important thing to note here is that they're saying that the sun is heading towards a solar minimum. Okay. Now, how long this minimum will last, no one knows. But it is said that before the sun goes into a main minimum, okay, because you have different cycles and different variances of minimums. You have your ice ages, you have minimums, and you have different lengths of those in between. So the time frame is so hard to determine. It's next to impossible. So we're still trying to learn a lot of this. But it's said before it goes into those minimums that there is a massive release from our sun, because we can see it in our geological records. We're seeing these large releases, and it's lining up with these minimums and ice ages, and they're starting to gain an understanding of what happens. And it makes sense. If the sun is going to a minimum, then that means that the sun's magnetic field has diminished greatly. Okay? But the solar dynamo is still ramping up. It's still stretching that toroidal field. It's still making sunspots, and it's still creating a massive amount of energy. But the overall magnetic field of the sun is diminished. which means it won't contain what it normally would in any other circumstances of what the solar dynamo does with the toroidal field and the sunspots releasing energy, along with the coronal holes. The coronal holes, that's a whole nother video. That's a whole nother thing we'd have to, that's a whole nother thing we'd have to get into. That's earthquakes. That's a direct connection to the surface of the sun, basically. I mean, that's a long thing. We're going to cover solar flares because this is very, very important. And I want to really point out the Carrington event of 1859, because what happened was it completely fried all the telegraph wires. Okay? Now, can you imagine if today we had something like the Carrington event, or much stronger, which we know the sun is capable of? And actually, we are actually overdue for a very, very large flare. Just so everybody knows, we're within 100 years and over, plus or minus 100 years, of having a huge flare from our sun. Now, you'll hear, oh, it'll give us radio disturbances. Oh, it'll mess with our satellites and this and that and the other. But we have never experienced the amount of energy that the sun is capable of releasing. Modern man has never been through something like that. And our technology, there's no way it would be able to take that amount of energy being induced at the L-shell magnetic field line of the planet. This would induce discharges. This would induce EMPs. I mean, you're talking frying computer chips. You're talking about shutting down all the power. At least to half of the planet, if it does not wrap around to the dark side. I mean, this is very serious, people. Because, I mean, it's one thing if you lose your power at your house, okay? That's one thing, okay? But if a nuclear power plant loses its power, and its backup generators, the computer chips in it are fried, and all the wires are fried, then there's no way to get cooling water into the reactor to keep the fuel cool. It will then melt down, it will then produce hydrogen gas, and it will then blow up. And with no one coming, no off-site power, no way of manufacturing any more chips, no way of getting help, no way of doing anything, it would be absolutely the end of our civilization. Absolutely. It would be the end of all life on this planet. Because just having the power off would kill millions of people within the first year. Millions upon millions of people. But then you add 450 plus nuclear reactors and test sites and, viruses, places where they, study viruses and all these other facilities that we don't even know about. Anthrax places where they put anthrax together and do studies on it and weaponry and whatever. We know what we have around this planet, and we will not survive if a huge X-class flare is released from our sun. It just won't happen. We will not survive. It just can't. With our water cycle, with the way it is, with our atmosphere, it's the whole reason why we should never have nuclear power to begin with. This is the entire reason. Because it is this dangerous to wipe out all of civilization. All life on this planet, except for whatever we can find in our spent fuel pools, bacteria or whatever it is. All complex life would be dead. the DNA of all life would not be able to make the correction. The genomes would be destroyed. So, this is a very important topic. I personally believe this is to be the most important topic our society has ever faced. Absolutely. And it's not just because what the sun is capable of. It's what we have on place on this planet. I'm going to start pressing this point because this is more important than anything we have our attention on at the moment. All this COVID stuff, none of this matters if the sun does what I think it's about to do, personally. I hope I'm wrong, but no one can know for certain. If it is going to a minimum, I believe it will release some sort of major release of some sort. Absolutely. I think we've crossed over what's called the galactic current sheet. Now this will be new terminology coming into the future. It's just like the heliospheric current sheet that the Earth crosses every 7 to 10 days and changes the phi angle. There's a phi angle shift every 7 to 10 days on this planet. Many of you don't even know. But it does change the magnetics of our planet and does change things on this planet when it does it. The same thing would happen to our sun if it crossed a galactic current sheet. I also wanted to make one more point before I go. Does anybody notice the sun is much, much, much brighter nowadays? Isn't it like a white? It's not yellow anymore, right? That's not just our atmosphere. I want to make the point. The sun fuses hydrogen atoms together. It also fuses helium atoms together. Helium fuses at a higher temperature than hydrogen. Wouldn't that make the sun fusing more helium than normal? Because the actual color of the sun is white. It always has been. It's not yellow. It's yellow because it comes through our atmosphere. But I don't think it's just our atmosphere breaking down. It's the magnetics. It's the sun. It's changing. Everything's changing in our solar system. All the planets are changing. The spot on Jupiter is fading away. I remember as a kid, it was huge. It was a huge discovery. Now it's fading away. There's so many changes happening to all the planets. And this is why. There's a change happening, and we all feel it. The KP index, the K indices, the A indices. This changes our brain chemistry. It affects those with mental disabilities differently. It causes heart issues and cardiac system problems, cardiovascular issues. And this is very, very important, people. Very. We need to get, in the least, all our nuclear reactors shut down into cold shutdown at least. And get all the fuel into spent fuel pools, because it takes 5 to 10 years to cool this stuff off enough for it to be put into a dry cask. So we need 5 to 10 years before it does it, because the same thing will happen with the spent fuel. if the pools run dry. It will build up hydrogen gas in the buildings, and it will blow once it meets oxygen. Man, it is beautiful though, isn't it, to look at? It's just a beautiful thing to watch to me. Watching those different ripples and how on one side affects the other, like the bottom right now. Wow. That's just cool. So check out this site, SDO, Solar Dynamics Observatory. And thanks for watching my video. I appreciate every one of you. I appreciate your comments. I appreciate your thumbs up. I would like to get more subscribers. I'm not begging you. You don't have to subscribe to me. But I have some plans into the future with this channel where I'm going to be bringing you different stuff like today. I normally focus on Fukushima and fission and nuclear physics and that type of topic, but there's a lot that I know. There's a lot that I can speak to. I can speak to political theater. I can speak to cosmology, geology. There's engineering. There's a lot of things I can speak to. So I have some plans with this channel. Hopefully some live streams coming up where you guys can come and we can talk about things, anything you want, as long within reason. I'm not talking about reptiles, people. I'm not talking about crazy things. I'm talking about real things that we can do something about right now. I'm not talking about crazy stuff, guys. And I'm just not into that. So I prefer to focus on things we can do right now. That we know right now. That isn't silly. I mean, come on, guys. You can't believe everything you see. Not even me. Honestly. If I'm to be honest, you can't believe everything I say. But I try to always bring you 100% as you can believe it's 100% true facts. And I do it better than I think most people. I think this is a very underrated channel. I could do things better, yes. I could present things better. I could do things better, but at the moment I don't have the greatest of setups, and I've been through a lot, guys. You just don't even know. We all have, but I've been through a lot, so bear with me. Stay with me. I appreciate all those who have, and I'll make sure you're not disappointed in the end. So, all right, guys, have a great week coming up, and you'll be hearing from me. All right, bye.